Hello everyone, welcome back. I'm Ishwardhan, currently studying in Sri Venkateswara College of Engineering from the Department of Computer Science and Engineering, Cyber Security. In this video, we are going to discuss about Kruskal's algorithm. Introduction to Kruskal's algorithm. What is Kruskal's algorithm? Kruskal's algorithm is a greedy algorithm used to find the minimum spanning tree of a connected undirected graph. The minimum spanning tree is a subgraph that connects all the vertices of the original graph with the minimum total edge weight. Minimum spanning tree. A minimum spanning tree is a spanning tree of a connected undirected graph with minimum possible total edge weight. It connects all the vertices of the original graph while ensuring the sum of the edge weights is minimized. Minimum spanning tree have various applications in network design, transportation, and infrastructure. Steps for Kruskal's algorithm: sorting edges. The edges of the graph are sorted in ascending order of their weight. Second step is select edges. Edges are selected one by one, starting with the edge with the smallest weight, as long as adding the edge doesn't create a cycle in the minimum spanning tree. Third is build minimum spanning tree. The algorithm continues selecting edges until the minimum spanning tree includes all the vertices of the graph. Example: consider an undirected graph. So we need to remember that the graph is undirected and it does not have any directions. We need to reach all the vertices with minimum weights, and no cycle should be formed, and we need to list the minimum weights. If we consider an example as shown in the figure, first we need to take the minimum edge or shortest weight. So we will take 1 as the shortest weight, and it will reach us from source to destination B to D. Next, we will take 1 as another shortest weight. So it will reach us from F to G. And then we will take the shortest edge or the minimum weight as 2 from A to B, source A to destination B, and then we will take the minimum weight as 2 from source D to destination E. Then if we consider the minimum weight 3 B from B to E, it will forms a loop. So we will neglect the edge. Then if we consider the minimum weight as 4 and it travels from the source B to destination G, and if we consider the minimum edge as 5 and then it travels from A to F, so it will forms a loop. So we will be neglecting the minimum edge. Then if we consider 6, so it will travels from the source G to destination C. And if we consider any others edges 7, 8 and 10, so all these minimum edges they will form a loop. So we are neglecting those edges. So after that we will be getting a minimum edge spanning tree as given below, which travels from A to B with minimum edge 2, and B to G 4, and G to C 6, B to D 1, and D to E 2, and G to F is 1. So it will forms a minimum weight of 16. The time complexity and space complexity is, in the worst case, the time complexity is O log E, and space complexity is theta E, and the average case time complexity is theta E log E, and space complexity is theta E. So advantages and disadvantages of Kruskal's algorithm. Advantage: it is simple to implement, efficient for sparse graph, handles graphs with negative edge weights. Disadvantages are less efficient for dense graphs, can be slower than Prim's algorithm for some graphs. Thank you.